Okay, slide 3. Slide 3. Oh, I see. Wait, but there's nothing from slide 1 and slide 2. Those used for contents starts from slide 3, right? Oh, okay. Give me 1 second. I got something ready from my oven. Give me 1 second. Ready. It's ready. What? What?
You put anything on it?
No.
Okay.
It's sweet. Okay, I'm back. So slide 4. Yeah, well, this is both are adaptive immunity. So this one go through B cells, and that's one to T cells. So what you want to know is this antibody type of immune response happens like for this extracellular antigens. So that's from B cells. So these antibodies binds something outside the membrane, but the T cell is more like, say, the intracellular pathogen. So it's just like the virus. So this one sounds like the virus before entering the cell. So you're gonna targeting those virus itself by these antibodies. But this is like when the virus stuff has something expressed on the cell surface, then you can have the T cell can recognize those receptors on your cell. So I would like to say like this part it's trying to look for something that is specific on the pathogen, like from the extracellular antigens, but this part is something you want to know is something happened, like something abnormal happened on your normal cells, so which can be recognized by the T cells, like the cancer, like the PD1, the anti PD1 stuff. Then, but yeah, I don't think he will test on this into detail. But this one, I like the question he went through in the class later to see that which one has the FC domain and what FC domain's job. So yeah, basically you want to know you have some ways to name different parts of these antibody. So if you're saying like this is like heavy chain, so heavy chain is actually one peptide chain, and this is another peptide chain. So you have this disulfide bond covalently link these two. But these are two different peptide chains. So that's from wait, I'm opening up my So that is from like a structure view, a molecular view. These two are different molecule, but they are covalently linked. But from the function view, they call it Fab domain and FC domain. Well, FC stands for crystallizable, but I guess it's easy for you to remember like like A, B, and C. So Fab, the function of Fab is for the antigen binding. It's for the recognition of the antigen binding site. Of the antigen with this antigen binding site. Further down, okay, so I guess this one. Oh, which one is Fab and FC? I mean, this is Fab. I guess there is a here. So if you call this like IgG, so this dark blues are heavy chains, and this one is light chain because light chain is smaller, so that's why it's light. This part called FC domain, which is the well, you can see like from here, but these two called Fab. Yeah, actually they call it Fab with only one end. This end called Fab, If you have two fab that was linked here, that is important. It's not only so compared to IgG or entire IgG, it's like Fab plus Fc. If you have only Fab, the bonding affinity theoretically doesn't change because these are the part for the antigen bonding. But one thing that why we use, sometimes we want Fab because it's small. Sometimes we want the entire IgG, or sometimes we want this only upper part called Fab prime, because of this action of the antibody. So they're not only neutralize the antigen, there are also some other functions that actually also play an important role in getting in the immune response. So neutralize is basically I got all this fat. I got all those like antigen binding domain binds on the antigen, so that I block this from binding to the target, or I just block that. Sometimes the antigen may be in a trimer, or maybe in the trimer form. So you bind that, you kind of disable or stabilize or destabilize some certain states. So after a long time, it will just get deactivated. So that's called neutralize. But they also function as agglutination, or this called opsonization with phagocyte. So which is like here, if you can, so the bivalent of the Fab can bound to several, or like, well, not several, but probably at least two sites together, and kind of trigger its aggregation. You know that sometimes when protein goes aggregation, they're just like, it's not that, it's gonna be denatured, or in this case, it's gonna be like either the protein got denatured, or it formed a large like a cage stuff, like larger size, and be recognized by other stuff. Or this time you have Fab binding here, and also this phagocyte also recognize the Fc domain, so it can be recognized and then bite the entire thing. So in this case, I'm not so sure, but for the neutralization, only Fab or Fab prime could be good enough, because it just need the interaction. But for this one, you must have, the antibody must have the Fc domain, because the Fc domain going to be recognized by this phagocyte. So this function should have a Fc domain, but this one does not need. This one Fc domain is not necessary. But I'm not sure here, because here when possessing a Fc domain, it help stabilize an entire structure. So this one probably is better to have an FC domain, but here definitely you need to have FC domain. Or later we call it ADCC. Yeah. This one also need to have an FC domain. FC domains are necessary because there are like natural killer cells that can recognize the FC domain. So it's like a recruiting of natural killer cells. Then here, all different kind of immunoglobulin. I don't think those are really important, but what you should know is that what is Fc gamma receptor? Oh, I forgot, but Fc gamma, well, you can't just, well, you will just say that it's like a, receptors that recognize the Fc domain or kind of specific Fc domain. So these receptors are on the killer cells. So when you have, say, this is a pathogen, when you have the antibody bond here with the Fab, then you still have this Fc domain. Then this gonna be recognized by a killer cells with the receptor, and the receptor bind here. So you kind of recruit the killer cell here, and killer cell, oh no, okay, here I know there's a pathogen. Then the killer cell come to kill the pathogen. I can search specifically about Fc gamma because I'm also okay. So there are Fc alpha, beta, and gamma receptors. So they are just named by the different mechanism of the receptor binding. So Fc gamma, as I know, when I study, when I have read some papers about the ADCC, so most of time the ADCC, you want to recognize multiple FC. So you want to know there's not only one antibody bond here, but also like the other one, the other one, and the other one. So they are all recognized by the receptors. Then the killer cell will come. If there's only one antibody bond here, it might not be enough to recruit the killer cell. So yeah, so while here you don't need to think that much deep, you just say there's a receptor that recognize Fc domain. So that's on the killer cell. So that's on the effector cell that came to kill that pathogen. Going further here, IgM, Ig, whatever. Here, so there are two ways you should know the difference. It's the T cell independent. So it does not need a T cell to come. So no helper T cell, just base cell is enough. Well, so yeah, so likely, like here, for IgM, I guess you should know it should be the largest one, and also it's the first line of defense. So cell secrete IgM first, so IgM will have a relatively low affinity or specificity because you just it is like something I want to it's like something that I want to have a rough idea on what's going on. So I have something that's like broad with lower binding affinity or with lower specificity. Okay, then yeah, it's like I do like first round selection, which is really rough. But after that, the B cells got activated by IgM oligomerization, then it can secrete IgG. Then IgG will undergo affinity maturation. That's called this VDG recombination. I guess you should know about the mechanism here is going the recombination. So basically, that region, I guess it should be in the gene level, DNA level. It goes through recombination really quickly. So when they reflect to the protein level, you will have those binding site with a little bit different amino acid sequence. So a little bit different local structure. And then you do then you know it's like a nature selection. So it goes round and select for those better mutation that can bind on the antigen. So that's called affinity maturation. But what you should know is that generally, or based on our research study, there's always affinity maturation, but the neutralizing ability is not equals to their binding affinity. It's not always related to the binding affinity, but most likely it's a rough idea that they should bind tight enough for its neutralizing for the neutralization, but it's not always like that, or most of the time it's not like that. So there's also some other considerations to take place. So these two are not equal to each other, but it does go affinity maturation. So that's called entire lineage of the antibody evolution. So here, you could have, say, so we have normal IgG. So this one is like a bispecific. So you have one light chain, one heavy chain from this side, this set, and another heavy light chain from another set. So these part and this part can recognize different antigen. It's used for treatment purpose because sometimes this one can actually reduce the off-target effect, because sometimes you want to know that we're not only recognize this part when something going wrong. So there are two lights are shining, so you want to sense both shining light, then react, but you don't want to be like this one only. Then if you have IgG recognized by this one, then you'll have off-target effect. You're gonna have like side effect like that. But you want to this specifically recognize this to happen on the same time or both occurred. So then that's the idea of having this bispecific antibody. Fab and so so antibody is used to recognize the antigen. So people are trying to make this smaller, have the better some physiology consideration. So they want to make this smaller, but still with its binding affinity, which is like binding event with the antigen. So Fab like this, you have like Fab or light chain, heavy chain, or you just want the variable loop, just this loop with the binding site, and then you link this together because you wanted this to be stable. So these interaction is not stable enough for this to be together, because here there's a disulfide bond, but here we don't have the disulfide bond, so we have to covalently link this two, and also they have to be in the exactly same structure as this one. So this is the one of the case study. I won't go through this, but you should know the idea. Again, this might be a open book, or at least a pseudo open book final. When you sense these drugs in a paper, you should reflect to this slide or say I know what it's talking about. Yeah, this is about the entire monoclonal antibody and Fab. Then here, what you want to know is that there is a specific FC, let's call that, okay, specific FC receptor actually can recover some antibodies back before going to lysosome degradation, which kind of saves something from the pool, which kind of increase their half-life. Also, as Abhi said, the FC domains are actually kind of be like recycled together because you have this mechanism that can recognize FC from degradation and recover it back. Okay, this one, antibody drug conjugates. Well, so this the idea, say, is like a drug delivery idea. So the drug conjugate to the antibody, so it will send to the specific destination where antibody can recognize those uh, receptors on the cell membrane. So there definitely should be some like a specific, some receptor specific to different type of cells or different tissue. Then you have this antibody, then you can deliver the drug there. This one is usable. Well, I can imagine to have a question on nomenclature, but just give you like a name of the antibody and ask what is this for, or what is this from. So I kind of have seen a question from past year, so they kind of should memorize these, at least these these abbreviation, what these stand for. But for sure here, because it's open book, well, you just need to know, or you take a summary, or like say, or just give a summary and say, okay, nomenclature, something stand for like O stand for mouse, like Z stand for human, whatever, for like cheat sheet type. So once when they ask you about this drug, where this antibody from, in the exam, then you should know. You should choose the correct choice. But this may be easy. This may be easy when it's open book. The T-cell receptor. So you can also regard this as an antibody, but antibody is the protein that's secreted from the B cell, but here is something on the T cell. But still, there's part of these T cell receptor that can go hypervariable, that has a hypervariable loop, like that can go dramatically somatic recombination to have this to kind of explore a larger structure space for the bonding. And yeah, that's the thing. So these cytotoxic T cell, probably you want to know this one. Is a Nobel Prize study of the cancer treatment, where if this is tumor cells, the tumor cells, when the tumor cell has like evolved to express the PD-L1 on the surface, so the T cell, the PD-1 can recognize here and say, okay, you're good to go, and then that's just past the checkpoint. But here, you want to block this one, so the T cell will not recognize this cell. Then this cell cannot be allowed to not differentiate to proliferate anymore, and then they go into the cell death. I haven't go to this stuff. Immunosuppression. Immunosuppression. Also, the HIV virus also target on the T cell. T cell therapy. Well, that's it. Tomorrow I will go through the problem set from Dr. Wang. So, have you tried on that? Oh, okay. So, do you know all the other? I mean, the arrangement of all the other finals that you guys have? They're not on the same day, right? It's not back to back anymore, luckily. I don't think that's same number of questions, because all the 3 midterms we have taken have different number of questions. Okay, cool. So this one's gonna be the first one. I don't know, but I don't think there. Well, so there should be MCQs and short answers. I guess the short answers may be like calculation, or I don't know what Abhi will give, because this part, if it's open book, then it's not that meaningful to ask you for the definition. But I guess more or less there should be about 20 points or 30 points of MCQs with 20 points of short answers. Like, I guess it's like, it should be like the last time. I guess the reason he said 1 hour time limit, because anyway you won't have another back-to-back exam after that. You just need to submit that Did he mention, will this be on the fixed time, or you can start anytime on Monday? At 2:30. Okay. Okay, so you guys should start on 2:30. Okay. Or I guess saying 1 hour just because this is online, so you may have start on the different, maybe like 1 to 2 minutes later, or you should give us like something delayed. But I don't think having extra 10 minutes will definitely means having more questions, because either way, most of time I would preview the question that has a timed trial. So most of the time the references double the time I have spent. So like last time the last exam, previously there are 18 or 20, no, there are 23, 25 MCQs with the same structured question. I finished that in 25 minutes. So if you double that, that's exactly 50 minutes. Then we thought you guys just after exam from the PCU class, maybe 50 minutes is too tight. Oh, okay, yeah, I think so. You don't need to be worried about this. But yeah, you can just tell me like how long do you need for your last midterm, for the midterm 3? How long do you guys need just to finish those questions? Like the midterm 3, you think? No, I mean the one with 15 MCQs and those 2 structured questions. Like how long do you guys need to finish that one? Because this version with like 8 or 10 MCQs less, then I'll spend about like 18 to 20 minutes. Right. So because I mentioned that for midterm 3, I got like 8 MCQs out from the first draft. So for me, I need about 20 minutes. So if we double that, that's about 40 minutes. So we think that should be enough for you guys to complete in 15 minutes. So for sure, this time there's definitely enough space for you. Yeah, I think so. Yeah, midterm 2. Yeah, I guess should be similar to midterm 3. Let me get my stuff. Yeah, should be good enough. Don't worry. Oh, um, I will control that. I think if there are too many questions, I can talk to Abhi. Uh, I'm thinking that tomorrow, because tomorrow we'll go through her questions, so I can kind of trace back to the original slides. I mean, she didn't record her third either, right? There's only the transporter 3. That's the fourth one. I guess she had only like recorded a few minutes of the third one. But first one, I have gone through her first lecture yesterday, which is a overview, right? Yeah, I may. I will. I will go through the second, third together with the practice question tomorrow, because you know that those are related. Yeah, I'm trying to find a way um um to summarize or to draw or write a workflow, because based on the practice questions, she might just ask something about like something going up or going down. So we should have a rough idea on the effects and on the reason on the cause and effect. So I'm thinking of making a workflow. I mean, yeah, because this is kind of open book. So it will be helpful. It will be even more helpful when you guys making a summary, so that you could either know the overall structure, or you have the idea, like this question we can look for which slide. how to make a summary. For her part, I guess there might be a summary on the like the PGP and ABC, other ABC transporter, their function, whether it's getting stuff in or efflux, get those stuff out. So and if there are inhibitor, then yes, but there are some case studies, right? Because personally, I don't like these memorizing stuff. It's just try to make something more logical, and can be, yeah, well, it's trying to find a hidden rule that can be applied. Then every time you think about one type of question, you just need to apply this rule into it. That might be easy. So I personally don't like those memorizing stuff. So I actually that's why I love the midterm 3, because those ideas are actually very you have to understand that first. It could be very logical for you to go through once you understand. So you don't need to memorize all those stuff. We should find a way to study those transporter events in a logical way, because that's science. We definitely will find a way other than memorize it only. But I don't think she mentioned anything that requires you to memorize the drug names or something. But from Abhi's part, he definitely wants you guys to memorize or to actually know those big names. Yep. We should. I think that's all for today. How's your guys' presentation? Oh, I heard like everyone just got 35 seconds to present, right? Or is it every group or every single person? Oh, cool. Well, okay. I'm gonna end today's session. So, yeah, I will go through the practice question tomorrow, together with some ideas about her part. So in this case, she has 4 lectures, and Abhi has 1, 2, 3, 4 lectures. Cool. See you tomorrow. Roughly. So that's also okay. So the thing is that they're just giving their question individually. Then I just go through it and talk to Abhi, and Abhi just combine them together. So that's also the reason why we got reduced number of MCQs in the midterm 3, because to try to balance the points from both parts. The definition question, that's 12 points. So he got total 22 points. Then Edie's got the other 28 points with 10 MCQs and the 8 points from the calculation. Yeah, I would say roughly 25. Okay, that's the end of today's streaming. Oh, don't worry. Hi.